All right, here we go. We are going to do section 6.4. We're not going to finish 6.4. We don't have enough time. We have 10 or 5 minutes, okay? But I can get through several things here, and that's what I want to do. So, again, this is rectangles, rhombi, and squares. Rhombi is just a plural. These are all plurals right here. Rectangles, squares, and then rhombi is a plural of rhombus. So let's take a look at the first theorem. I'm just going to draw it. I'm not going to write it out. And what does that thing look like? Just by looking at it. Looks like a rectangle, but can I say that it's a rectangle right now? Not really. Actually, more than not really. I absolutely cannot say it's a rectangle unless I do this. Okay. Now, if I do this, now for 100% sure you can tell me this is a what? Rectangle. So what we're going to do today, we're going to get a little more specific. We've already talked about a rectangle, haven't we? Have we or not? I don't know. I think, yeah, we have. We talked about a rectangle. We're just going to get a little bit more detailed about the rectangle, all right? So we've discussed these things before. What's this when I go from one corner to another? That's called a what? Thank you. It's a diagonal, okay? It's a diagonal. You guys are scaring me. We've done diagonals before, right? Haven't we done them? Yeah. All right, so that's a diagonal. Okay, so both those red ones right there are diagonals. Now, here's what the theorem says. We have learned something about diagonals on parallelograms. Do you remember what's true about diagonals on a parallelogram? On just any general parallelogram. What's true about the diagonals all the time? They do what to each other? They bisect each other, okay? So that would be true here as well, okay? But they do something a little bit more than just bisect each other when it's a rectangle. Again, this only works when it's a rectangle. Now, let me say one thing before we move on, though. If it's a rectangle, if it's a square, then it's also a what? A rectangle, okay? So this would be true about squares as well. Now, there's something else that we'll get to, I don't know if we'll get to today, but at least tomorrow we'll talk about the diagonals of a square, okay? And they do something a little bit different. So right now, these diagonals, now again, I've said this before, your gut instinct, just looking at it, what do you think might possibly be true? That doesn't always mean it's true, but it probably is in this case, okay? Look at the two red lines right there. Now, they do bisect each other. We know that. But we also know, what do you think might be true about that length of that diagonal and the length of this diagonal? What does it look like to you? Just look like. Looks like they're equal to each other, and they absolutely are. Okay, so if I called this, actually they start here. I'll just be consistent with my notes. All right, that's right. If it was a parallelogram, it doesn't mean that they're equal to each other, okay? The only time when the diagonals are equal to each other is when it's a what? Rectangle, all right? So if it's a regular parallelogram, they always bisect each other, but it doesn't mean that the diagonals are equal to each other. Does that make sense? What does it mean to bisect each other? They do what? They split each other, what is it? In half. Very good, okay? So we know that they split each other in half, but since this is a rectangle, so our theorem, I'm not going to write it down because of time, but our theorem says that the diagonals are congruent to each other. So let's mark it, instead of writing out the whole theorem, let's mark it with some letters and equals and all that kind of stuff. So what's equal to what here? As far as our letters, using our letters here, what would be equal to each other? Say it real loud. I can't hear you. I got this fan from this computer blowing. I can't hardly hear you. What's this? B what? BC and AD. BC? Is that a diagonal? Listen, I said what the diagonals are equal to each other. BD, right. So BD, line segment BD, is congruent to, what's the other diagonal? AC, all right? Or you could say CA, doesn't make any difference. So either way you say it, that would be fine. Actually, you know what? I'm going to write this because you could say it like that. Or you could just say that BD is equal to AC. What's the difference? This just means that if I took one diagonal, picked it up, put it on top of the other one, they would match up. This one means the measure of. So if I knew that the measure of BD, watch, what if I knew the measure of that whole thing was, 20, then what would the measure of AC be equal to? It'd be 20 as well. Now, let's just use that number right there. What would the length of, let's call this x. What would the length of bx be equal to? It'd be 10, because you know a rectangle is a parallelogram. The diagonals bisect each other. So if you know the whole thing's 20, then you know that bx is 10 and what? xd is 10. All right? But what did we say about AC? AC is also equal to what? Give me a number. Give me a number. AC is equal to what? 20. So that means AX has got to be what? 10. And CX has got to be 10. So when you have a rectangle, all four of these segments right here to your diagonals will always be equal to each other. Everybody see that? Yeah. All right, so that's that. Let's do an example, and time went really quick. I don't know if that's true or not. Wow, that ended early. You kidding me? Here's what I'm going to do. Do this. Here's a little homework assignment for you. You're going to do this example. Write this down. J, K, L, N. All right? And put a couple diagonals here. Where are you going? I said hang on for a minute, and you're walking out. Bell doesn't dismiss you. You're not writing this down. Huh? You keep saying huh. This is a rectangle right here, okay? It tells you it's a rectangle, and it says that JL is equal to, I want you to do this for homework, this problem. JL is 5x plus 2, and KM is 7x minus 6, okay? That's what they tell you. So what I want you to do is I want you to find the lengths of those diagonals. I want you to find what JL, the actual number for JL, and I want you to find the actual number for KM. So you're finding both diagonals. This is how they give it to you, and I want you to find both of those diagonals. Okay, so that's your homework. Get that done. Come in with the right answer tomorrow, and we'll move on from this tomorrow.